All right, yesterday when we went over this content, we were in breakout rooms. However, I cannot record in a breakout room, so I am recording today's notes after the fact. That means that you're just going to hear me today in our video. So we talked about substitution yesterday, and that learning target, as a reminder, was 3.2.1a. We're looking at the first part of that. Previously, we had talked about solving a system graphically. Today, we're talking about solving it algebraically, and this is one of the two ways that we can do it. All right, so what is substitution? First and foremost, it is one of our methods of solving a system where one equation is substituted in for another. And there are some basic steps as to how to do that. So our first step is that you're going to want to solve one equation for x or y. Now, this would technically be a 3.0 version of this learning target. The 2.0 version, you are already going to have an x or a y solved for you. After we have one of our isolated variables, then we are going to substitute this expression into the other and solve for the variable. Now, thinking back to how we solve a system of equation and what our answer looks like, our answer is going to look like an ordered pair, x comma y. So what that tells me is that we actually have to solve for both an x and a y. So once we solve for one variable, we're actually going to repeat this process. So step 3 is to substitute and solve again. You have to solve for an x and solve for a y. All right, so basic steps down. Let's jump right into some examples. All right, example 1. Now, before we even start the example, I want to point out the first thing that you should do in all of these situations when you want to substitute. You should check for an isolated variable. And what that means, you are looking for an x equals or a y equals or an equals x equals y. We want something where the variable is all alone on one side of our equation. Now, looking at our first example here, we actually can choose from either of our equations because both of them, sorry about that, because both of them have a y equals. Our y is isolated in both equations. So you could choose either one to start with. Now, regardless of which one you choose, you're going to want to put parentheses around what that variable is equal to. So I chose the first equation. That's the one we're going to start with. Now, what this is saying, since y is equal to 4x minus 1, that's saying they're equivalent and they can take the place of one another. So I want to reflect back to that word substitute. When we think substitute, we could think of a sub in sports or a substitute teacher. Now, generally speaking, if we're talking about like a substitute teacher, if I was out for the day, somebody else would take my place. You would not see me in the building. I would not be in my classroom. They would be in both of those places for me. So what I'm going to do, I'm going to pretend that 4x minus 1 is our substitute teacher for y. So I'm going to rewrite this second equation, but I'm not going to put y. Y is out sick. Instead, I'm going to replace it with its substitute 4x minus 1. So what I'm going to do is I'm going to rewrite this equation. I'm going to have, instead of y, I'm going to have 4x minus 1 equals 2x minus 5. All I've done, I've rewritten this bottom equation. I've just swapped out this y for the 4x minus 1. That is the hardest part of substitution, recognizing where you need to plug things in. Once we get to this point, now it's simple multi-step equations. This is back from Unit 1. So I'm going to gather all my variables on one side. You might solve this a little bit different than me, but you should still get the same answer in the end. So now we have 2x minus 1 equals negative 5. This is a third wheel situation, so at this point I would add 1 on both sides, and I get 2x equals negative 4. We are almost done here. Our final step for our equation would be to divide by 2 on both sides, which would leave us with the final answer of x equals -2. Okay, so I solved my equation, but I want to pause to think about what this is. So a system of equations, we said your answer has to look like x comma y. So what I've done, I've found my x value. That means in my ordered pair, I can put that number in x's place. However, I still do not know y's value. That is still a question mark for me. So if we go back to our steps, I've done step 1 and 2. Now I'm just going to repeat that process. I'm going to have to solve for the second variable. So how I'm going to do that, I'm going to take my x value, what that is, and you can choose either equation here. It does not matter. You're going to now take -2, and that is going to be our substitute. So everywhere we see an x now, we're going to put -2 in its place. And again, you can choose either equation. So I'm going to choose the bottom one this time. So I'm going to have y equals, I'm just going to rewrite the equation first over here. And now I'm going to substitute. So instead of x, I'm going to put -2 in its place. And now it's just a matter of simplifying. So on this right side, I see those parentheses. That means we're going to multiply. So I get y equals -4 minus 5. And then since these are like terms, we can combine them. You would get y equals -9. So now I have an x value. I have a y value. I just have to make sure that they are in the right locations in my ordered pair. And I get my final answer of -2, -9. First example done. All right, let's check out a different type of example that we might see. I'm going to skip ahead to this one. All right, so again, we are going to do that first step, which is check for an isolated variable. In this case, again, remember we are looking for an x equals, a y equals, an equals x, or an equals y. Any of those will do. Before, in our first example, both of them had y equals, so we could choose. This time we only have one of those scenarios, and it is that top equation where we see the y equals, our isolated variable. So I'm going to put parentheses around what y is equal to. And now that tells me that x plus 9 is my substitute for y. So it's going to take the place of all my y's. So I'm going to rewrite this equation now, that bottom equation. But every time we see a y, we're going to put x plus 9 in its place. So here we go. I have 3x plus 8. Oh, instead of y, here's where I substitute. I have x plus 9 equals -5. And that is the big idea behind substituting. That is the big step that we have to take. Now it's just down to solving a multi-step equation. So I'm going to draw my line and go through my process of solving here. In this case, I would distribute to both things inside the parentheses. Don't forget to distribute to both terms. It's a common mistake. And we'd be left with 3x. On this side, we haven't changed that. We also haven't changed the -5. In parentheses, now when we distribute, we get 8x plus 72. Continuing on, I notice I have a couple like terms, so we can combine this 3x and the 8x to give us an 11x. Since they're on the same side, we didn't have to use inverse operations. And now again, we're down to that couple and third wheel situation. So I'm going to subtract 72 to get rid of the third wheel. And when we do that, we're left with 11x on this side. I got to extend that line. And -77 on this side. So for our final step to get x all by itself, we're going to divide by 11 to give us our answer of x equals -7. So what I like to do, after I finish the equation, ask myself, am I done? In this case, no, we're not done because we only solved for one of our variables. And I'm going to start my answer now. So that was our x variable. So in our ordered pair, remember, x comes first. So I'm going to write -7 in x's place, but I still don't know that y. That's still my question mark. I have to figure that out. So just like we did in our last problem, now I'm going to take that -7, and you can plug it into either equation. And I'm going to be honest with you guys, make your life easy. Pick the shorter looking equation. You're going to get the same answer regardless. No point in making your life harder than it already is. So I would, if I were you, use that top equation. So now this time we're plugging in -7 for x. That's our substitute. So I'm going to have y. I'm just going to rewrite the equation first so I know which one I'm using. And now I'm going to substitute. This time we're plugging in -7 for x. Since y is already isolated, all we have to do on the right side of our equation is to simplify. Since these are like terms, we can combine them. So we get y equals 2. So now I have my x, I have my y. We're going to make sure that those numbers are plugged into the correct location in our ordered pair for our answer of -7, 2. Now, what if I'm solving this problem and I'm like, ooh, I'm not really sure if I got that right. Oh, I want to double check it. There is a way to check your answer. So what I'm going to do over on this right side, I'm going to check. And you don't have to do this, but I would strongly suggest it on an assessment or something if you are wondering whether or not you got the answer right. And to check, what we're going to do is we're going to plug in both of those numbers. So go back to your answer, and we're going to label them x and y. And then what we do, we pick either equation. Again, it does not matter. I'm just going to pick that top one again. If you wanted to pick the bottom one, it's totally up to you. And you're going to plug in both the x and the y this time. So now I'm going to have my y value is 2 from my answer, and my x value was -7. And you're just going to simplify both sides individually. 2 is already simplified as it can get. -7 plus 9, that gives me 2. Since I got the same answer on both sides, I know I did it correctly. Yay! All right, our very last example that I want to do here, and then we'll wrap things up. This time, you'll notice that I do not have a y equals. This time, I have an x equals. That's okay, the same process. It's the same thing. It's an isolated variable. The only difference is that now we're going to plug things in for x instead of y. So just like I did before, we're going to put parentheses around our substitute. And now I'm going to take that expression, and anywhere I see an x, I'm going to replace it with 4y plus 7 in this second equation. So I'm going to have 2, and instead of x here, now I'm putting 4y plus 7 minus 6y equals 12. And here's a hint. If when you substitute, after you substitute, you see two different variables, so you still have an x or a y in your equation, you did something wrong. You need to go back and fix that. You should only ever have one variable after you substitute. And away we go. Now we're solving an equation. So boom, let's distribute, hippity hoppity, distributive property. And I get 8y plus 14 minus 6y equals 12. Again, I see some like terms that I would like to combine. When I do that, I get 2y plus 14 equals 12. And now we're down to our couple and our third wheel. So I'm going to subtract 14. And we get 2y equals 12 minus 14 gives us -2. Down to our very last step for this equation, all we have to do to get y by itself is divide by 2, which gives us our final answer of -1. Now, previously in our other examples, we had solved for x first. Now what happened? We found y first. That's okay. We at least got one number. We're just going to want to make sure that we put it in the right spot in our ordered pair. Since this was y, we need to make sure it goes in y's place. Okay. And now again, I'm just going to do that same thing, but now I'm plugging something in for y. And again, you can pick either equation. I'm going to pick this top one because it looks easier to me. And I'd have x equals 4 instead of y. I'm going to put -1. And now we just simplify. Away we go. Distribute that 4. And because these are like terms, we can combine them. X would equal 3 in this case. And we have our ordered pair. Now, if you're curious as to whether or not we could have picked the other equation, let's test it out real quick. I could have, instead of doing this, I could have chosen that second equation to plug y into. We would have gotten the same thing. In that case, we would have had 2x minus 6 times -1 equals 12. Again, I'm just doing this if you didn't trust me that we could pick either equation. And I'd get 2x plus 6 equals 12. Subtract 6 on both sides, and we get 2x equals 6. Divide by 2. And we would still get x equals 3, which just shows that it doesn't matter which equation you plug into over here. All that matters is that you plug it into the right spot and you solve correctly. And again, you could check if you wanted to. It's a good idea, especially on an assessment. All right, if you have any questions, reach out to me. Thanks, guys.